This is part 5 of my Temple OS tutorial. Today we're going to be talking about general memory management and pointers. Even though I went over them a basic overview in the last video, now we're actually going to be going in depth on pointers. Pointers, they are just it's just a memory address. So if I have U32 number and it's equal to 32, this is making a pointer to number. And a U32 number pointer equals and U32. But this wouldn't work. You have to specify this is a U32 pointer. This symbol right here, the star, Shift 8, and this is Shift 7, ampersand. This is how you create one. But say if I want to use number pointer, we would have to use this to dereference it. This is how you make the type of a pointer. And this is also how you dereference pointer. This is how you make a pointer. And yeah, but what you also need pointers for is MAlloc, memory allocation. So if we want to go back to making our make p function, we would have to use a command that is very useful called MAlloc. This looks like gibberish. It stands for memory allocate. You might be saying, hey, doesn't making a making a variable make memory? No, it's a stack. Stack is a predefined memory that's just super fast. But if you want to make it, maybe over multiple functions, you would have to use MAlloc, which allocates to the heap, which is basically general memory. So, and also, you specify how many bytes you want, but if you don't know how big a thing is, you can do size of, then whatever it is, say, person. And then MAlloc, by itself, is pretty bad, because it just allocates something and you can't use it. So, what we do is create a void pointer, which is a pointer that you can turn into anything. But we're actually going to make it a person pointer. Is that possible? That doesn't look like it's very working. Person, P equals that. Let me just test if that works. Warning, unused var. Oh! Wait, no, this never ran, thank God. Okay, at the end, we still need to free, when we make memory, automatically it doesn't remove the memory from the heap. That's what you call a memory leak, where it creates memory and doesn't remove it after the program ends. So if we're going to use make p, well, we still need to add function arguments. We didn't really do that. So what we need is a U8 for name. Oh, excuse me. But we'd actually need to make that a pointer. Yeah. Wait, do we? No, I don't think we do. Okay, and then we'd make a U8 for the age. Usually, most numbers, you'd make like a U64 or I64, but for age, you're not going to be over 256 or under 0 age, so we can just set it as an unsigned 8-bit. Unsigned means no negatives, only above 0. So, right now, we've done that, and at the end, we're still going to free whatever we'd set it as. We'd MAlloc person, so then we'd have to set, oh, Frank, I'm in insert mode. Press insert, whatever you do will overwrite. It's kind of hard to use because it's useful sometimes. Not when you're trying to make new lines. So, P, and remember what you have to do here. For a function pointer, you have to use this instead of just dot. Or class pointer. Sorry, not function pointer. Use special things for that. And p.name equals name. Now that I think about it, we might need to make that a UA pointer. No. Okay, then that's good. Dash age. Sorry, that have it there. Age. Yeah, I'm aligning this stuff because that looks good. Ignore that part, that's not hard to do. Then what we do is return P. Alright, would that compile? U8? That's not a U8. In no way is that a U8. I'm not returning a U8 here. Okay, so then we'd make person P3 equals make P James. I like using J names. I don't know. My name doesn't start with a J. And then we'll also make sure at the end we always free whatever we allocate. Or else we'll create a memory leak. And no one will run your program because they'll think you're a dumbass. Okay, so let's go from... But what do we do if we need to say, greet? Let's see if greet works with this. B3. Compile. James your age 32. Yes, see? Okay, what's wrong here? Use U8. Okay, I'll use U8. That's fine. You really want me to? Hey, I guess we should have used A. See? And that's MAlloc. It allocates to the heap, which is used for cross-function variable storage, which means you can access it from this one, and even this one, if it really mattered. So, there's function pointers for you. But that's not where we end here. There's also another one, I think, MAlloc, that I'm actually going to check, because I don't know what it does. Accepts a C task. Oh, yes, this creates a different tasks. We don't need to care about that for now. But for now, I am honestly confused on why that needs to be U8, U0. If you use something that's a pointer for a different type, but it's a U0, it'll just automatically convert to that, which is very useful. But if you use it for a specified one, but use it as something else, I guess it will still work? I don't know. I'm a C programmer, so I'm not used to these things. And right now, we've passed the 8-minute mark, so I would say goodbye and see you next episode.